This is for 5th grade ELA. The story is called One Well, the Story of Water on Earth, written by Rochelle Strauss, illustrated by Rosemary Woods. Again, this is an expository non-fiction text. One well. Imagine for a moment that all the water on Earth came from just one well. This isn't as strange as it sounds. All water on Earth is connected, so there really is just one source of water, one global well, from which we all draw our water. Every ocean, wave, every lake, stream, and underground river, every raindrop and snowflake, and every bit of ice and glaciers and polar ice caps is part of this global well. So whether you are turning on a faucet in North America, pulling water from a well in Kenya, or bathing in a river in India, it is all the same water. And because it is all connected, how we treat the water in the well will affect every species on the planet, including us, now and for years to come. Earth is the only planet that has liquid water, and is therefore the only planet that can support life. You need water, and so does every other living organism. Every person, every plant, and every animal. Without water, nothing can survive. The amount of water on Earth hasn't ever changed. It has been the same for billions of years. So, this is an interesting concept, isn't it? That all the water in the world comes from one well. What are your thoughts on that? Do you think this is an opinion or a fact? So I just read the sidebars on page 5. Do these facts help you want to read the rest of the book? Why or why not? The water in the well. We live on a watery planet. Almost 70% of Earth's surface is covered with water. This surface water is found in oceans, lakes, rivers, streams, marshes, even in puddles in the morning dew. And there is so much water that if you looked down at Earth from space, it would appear blue. But there is always also water we can't see. Beneath the Earth's surface, this groundwater can be found just about anywhere. It fills the cracks in rocks and the spaces between rocks, giant grains of sand and soil. Most groundwater is close to the Earth's surface, but some of it is buried quite deep. Water is also frozen in glaciers and polar ice caps, and there is water in the atmosphere. Every one of these water sources feeds Earth's one well. So where is the water on Earth? Oceans, 97.23%. Ice caps and glaciers, 2.14%. Groundwater, 0.61%. Freshwater lakes, 0.009%. Inland saltwater seas, 0.008%. Moisture in the soil, 0.005%. Water in the atmosphere, 0.001%. And rivers, 0.0001%. Yes, there is more water in the atmosphere and soil than in all of Earth's rivers. Recycling water. The water we drink today may have rained down on the Amazon rainforest 5 years ago. 100 years ago, it may have been stream escaping a teapot in India. 10,000 years ago, it may have flowed in an underground river. 100,000 years ago, it may have been frozen solid in a glacier. And 100 million years ago, it may have quenched the thirst of a dinosaur. The amount of water on Earth doesn't change. There's no more water now than when the dinosaurs walked the Earth. The same water just keeps going through a cycle over and over again. This constant movement of water is called the water cycle. During the water cycle, water evaporates from oceans, lakes, rivers, ponds, and puddles, even from plants and rivers. It rises into the air as water vapor. As water vapor rises, it cools into tiny water droplets. This is called condensation. These droplets form clouds. Gradually, clouds collect more and more water droplets. The average white cloud weighs about twice as much as a blue whale. When water droplets get too heavy, they fall from the clouds in the form of hail, snow, or rain. This precipitation returns to oceans, lakes, and rivers. It also seeps into the ocean soil and down into the groundwater. Year after year, water continuously circulates through the water cycle. And I'm going to show you what it looks like. So you see it, shoo, go up, and it comes down. In 1 year, an area of rainforest the size of a football field pumps over 75,000 liters, which is 19,700 U.S. gallons of water vapor into the atmosphere, more than enough to fill a backyard swimming pool. It takes about 1 million tiny water droplets to make just one raindrop. Why are the oceans salty? Rivers flow into the sea, collecting salt from rocks and soil and adding it to the ocean. As ocean water evaporates, the salt is left behind. How thirsty is a tree? On a summer's day, an average-sized birch tree can draw about 80 U.S. gallons of water from the soil. That's almost enough water to fill 2 large bathtubs. Many plants depend on water to disperse their seeds. A coconut, the seed of a palm tree, can spend weeks, months, or even years drifting in the ocean before reaching land and sprouting. The plants you eat are mostly water. Tomatoes are about 95% water. Apples are about 85% water. Seeds are among the driest foods. They contain only 5 to 10% water. Plants at the well. The first plant on Earth began life in the water. About 450 million years ago, some were washed ashore. At first, they could live only in wet areas. Gradually, they developed root systems that allowed them to tap into water in the soil. Water is essential to plants. In fact, plants are mostly water. It's the water in their cells that gives them their shape and form. Without it, they droop and shrivel. Water also helps plants make food for themselves. Plants use the sun's energy to change water and carbon dioxide into simple sugars that feed the plant. This process is called photosynthesis. Water then helps carry this food throughout the plant. During photosynthesis, plant also release water vapor into the air. Roots absorb water, which is carried to the stem. The stem acts like a water pipe in your house, moving water through the plant to the leaves. From the leaves, water is released back into the atmosphere. This is called transpiration. The water that is transpired is added to the cycle of water on Earth. Water is important to plants, but plants are also important to water. Plant roots anchor soil and stop it from blowing or washing into lakes and rivers. Leaves and branches trap rainwater, allowing it to seep slowly into the soil instead of flowing quickly away. And trees provide shade, which helps keep moisture in the soil. Plants depend on water from the well for survival, and the well depends on plants to help move water through its life cycle. Without plants, the water cycle would be disrupted. Without water, plants could not survive. Animals at the well. Like plants, animals, including you, are mostly made of water. The water in animals is very important. It carries nutrients, helps digestion, removes waste, controls temperature, cleans eyes, and lubricates or oils joints. Water habitats are also home to many of Earth's animals and are where many animals find their food. Watery species such as fish, crabs, shrimp, and zooplankton are an important part of food chains around the world. Food chain is the link that connects animals and other species based on who eats whom. Without water-based species, food chains and food webs, collections of food chains, would collapse. Animals would starve. Animals not only need water to survive, they are also part of the water cycle. Animals add water to the atmosphere by breathing, sweating, peeing, and even drooling. The water you brushed your teeth with today may have been the spray of a beluga whale 10 years ago. Some of the wettest animals on Earth are the jellyfish. They are about 95% water. Frogs and earthworms are about 80% water, while dogs, elephants, and humans are about 70% water. All animals need water to drink. Even desert animals, they get much of the water they need from the food they eat. Animal life began in the ocean. Then about 360 million years ago, some animals started to evolve. Their bodies began to change, and they slowly adapted living on land. Okay. Now, what do you think about water in your top coming from a whale spray years ago? What message are you getting so far from this writer?